Welcome everyone, my name's Mark Hughes and I am here on behalf of Advanced Assembly, your original quick turn board experts. If you need a board and you need it yesterday, email sales@aapcb.com. For your convenience, this webinar will be recorded and sent to any registrants within a couple days of this. It takes us a little while to edit it down and do what we're going to do. But if you have any technical inquiries, please email mhughes@aapcb.com or kyle@allspice.io. Once available, you can find the recording and the slides as well at aapcb.com/blog, although we're not going to have very many slides for this. The webinar today features AllSpice. AllSpice, you guys are going to love this thing. This is GitHub for hardware engineers. As we go through, if you have questions, you're going to be able to ask them in the Q&A down at the bottom. Please don't ask them in chat since we won't be monitoring that. And with that, I think it's time that I introduce our presenter today, Kyle Dumont. Kyle, tell us a little bit about yourself.
Hey, Mark. Thanks. So my name, of course, Kyle. I'm the CTO of AllSpice. I spent about 7 or 8 years as a product developer in electrical engineering space, doing firmware electrical engineering. Ultimately decided it was time for a better collaboration environment for electrical engineering. I had worked a lot with PLM systems, worked a lot on the release process all the way from concept to manufacturing. Really admired a lot of the tools that I saw, especially in the software space for collaborating, reviewing, releasing, and automating tests. Wanted to see how much that we could pull into the hardware space. And actually, I spent I would say the latter part of my career at a hardware startup called Voxel 8. We were designing a new 3D printer. And even at that time, started to experiment with how we could use GitHub and other Git hosting services for our hardware collaboration. Found that there's really an appetite for that. I mean, we saw it in a lot of the companies we were working around and with in the hardware space where we're doing similar things. So founded AllSpice in 2019 with my co-founder Valentina. We started it basically during the summer of our MBA program. We started on this full time in 2020, so we've been about 2.5 years now. Last year, we launched AllSpice Hub, which is really our GitHub-esque product. If you're familiar with GitHub, the idea being a portal, a platform you can use for collaboration and revision control, documentation, design reviews, all those fun things for electrical engineering design files.
All right. Well, hey, man, let's jump right in. To prepare for this webinar, I went ahead and sent you a file from Mark Harris. Mark runs Original Circuit, and a lot of people haven't heard about Original Circuit, but most of them have heard of the Celestial Library, the largest open source Altium library on the web today, and he runs that all for free. So if you need parts and packages, I mean, he's got millions of them, all 3D modeled and footprints and everything. Look for the Celestial Library, and you'll find it. With that, we get to dig into one of the designs he provided us today. Let's do it.
Yeah, so when you sent me that design, he had hosted in GitHub. I did a quick migration over to AllSpice Hub, and this is where we're at. As I showed you a little bit, we have all the design files here. This is schematic docs, PCB docs, one for the board, one for panelization drawings, and the project PCB information as well. You can see kind of clicking in, we get a real-time view of the design that we can go through. In this case, we will most likely be spending most of our time on the PCB in a design review. I'll pause there, Mark, if there's anything in particular you want to go through.
No, maybe we could just slow down for a second, and for people who might not be using Altium, explain what the different files are.
Yeah, that's totally fair. So Altium has a project PCB files essentially contain the information for what files are part of this PCB assembly. The SCH docs, those are all schematic files that are part of this PCBA. And then of course the PCB, this is the raw PCB file, right? In this case, we can look at different layers and things like that if we're curious about only different aspects of it.
Okay. And today, I think we were going to go through a little mini design review, right?
Yeah, that's the plan. So one of the ways we see, a lot of our users using AllSpice is to conduct design reviews. In this case, I thought it would be really helpful to get some feedback on this design from you, Mark, for us to go through together and see, what are some of the things we can get, some of the information we can get from the design to hopefully design better PCBs in the future, and then do it in AllSpice, see if there's a kind of demonstrate how remote and a web-based design review tool can help augment the process like that.
All right. And maybe we should just take a second to talk about a design review because there's all sorts of different aspects. And I know you've put together a resource that some engineers might find useful. Would you like to share that with us real quick?
Absolutely. So there's a few different things that really get built into helping automate some of the design reviews. One such kind of supplemental tool we have is a default design review checklist. And so essentially what happens is you can configure, per a repository or per your organization, you can have a automatic design review checklist pop up that will just help you catalog, what kinds of things you've gone through, what still needs to be reviewed. Everything we use in AllSpice Hub is all it's all Markdown supported. So if I come in here and edit this, I can configure things to basically match what I need, get some light, formatting from Markdown. So you'll see a bit of this. And if you're not familiar with Markdown, super simple. We can also provide some more info on that if anyone's curious. But just gives you some simple formatting without, going over the top like a Microsoft Word or something like that.
All right. Yeah, the design review is just a little bit different than what you might do on your board, an ERC, electrical rules check, making sure there's no short outs on the nets or anything like that. Or even your design rules, where you go to your schematic and say, okay, I've got a 100-volt net here. It needs to have a minimum of, say, 15 mil spacing to any other net. Well, you're looking for other things too. And engineering's such a complicated subject. You can get bitten in the butt by so many little things just over and over and over again. It always helps to get a second or even third set of eyes on a project. I've got a project right now for a different company, and I can't share which one. It's an NDA, but we actually ordered our board through advanced assembly, and we put multiple designs on one panel. Well, one of the projects, one of the engineering teams made some mistakes. They've got some 0603 resistors going on 0402 parts. They've got some LEDs where we don't really know where the anode and cathode are. That's a pretty common problem. Those are DFA, and those can sometimes get caught in the design review. Other things, did you read the data sheets? Did you implement the required things correctly? Like if you're doing a power boost circuit, did you correctly calculate the resistor divider for the feedback pin? All sorts of stuff like that. So let's hit it, man.
Yeah, that's exactly that last one is exactly what we ended up finding here. Turned out that in one of the last revisions of the design, they were using the wrong resistor value for the feedback divider. So we created a new fix for this. In this case, we have opened a design review to resolve that. And this automatically will show you basically the delta, how the design files have changed in this new version compared to my latest main version. One of the key changes is this one here, as Mark just mentioned.
All right, so it was sitting on top of it. So it was a 10K before and it's a 2K now.
Yep. Yeah. So
So
previously 10K.
on a 3.3 net, we're going from a 2-volt feedback voltage down to like a 0.8 volt feedback voltage. So yeah, somebody just picked the wrong resistor. It happens.
Yeah, and I think as we were looking at it, think it would, if you looking at the spec sheet, seems like something in like a 16-volt output that this thing was shooting for, which I'm not sure what the limits of this this controller are, but that seems regardless problematic for your 3.3-volt design.
Definitely, definitely, definitely. All right, so where should we start? Do you want to go over AllSpice or do you want to jump right into the design review?
So I think we've touched on AllSpice a good bit. I'm sure our folks here want to talk a little bit about the PCB design. So we can kind of jump into doing some reviewing the design a little bit here.
All right. So should I open that on my end too and make some comments, or how would you like to go about doing this?
Yeah, that's one of the most probably the best way to work through this is because we're in a design review here in AllSpice Hub, we can basically live comment back and forth. Of course, the simplest way to do that is if you're just leaving a text-based comment or some links, you can of course throw those right in the comment box below. But hopping over to files changed, you can actually comment directly in the design that we're going through, right? So right off the bat, if we wanted to say, whether or not it's something we changed, maybe I want to grab this design. By the way, Mark, let me know if you need me to update you with the link for the PR here. But I can also tag you so you get a nice notice here. At Mark Hughes, did this connector, maybe this connector was EOL or something like that. Get reviewed.
Okay, and then I will on my end see if I can't find something useful as well.
Yeah.
And I think I might have found something. I'm not sure, but I'm going to put something in.
Yeah. So just to wrap on this, I selected a piece of this design. We're going to get a notification here. Since I submitted it as a comment, you'll see that on the main page as well. Hopefully click right through it and come back here. Of course, just for your, quick overview of the design tool, you can of course toggle off layers. So if we just wanted to look at, how are my vias spaced on the top layer, we can kind of get an idea of that. Of course, we can see also how the planes and cutouts are. We probably want multi-layer on too.
Is there a way to increase the size of that screen?
Yeah, so this one, not currently. I mean, of course, we can always zoom in and reshape the browser screen. Let's see how that does for me. And then go from there. Of course, I blew up my avatar with that, but
Haha, you blew up your avatar.
so yeah, that's kind of one of the current views, because the PCB is basically this long kind of strip line PCB.
Right.
It is a little interesting in the web view. Mark, do you want me to pass the driver's seat to you?
If you would like me to, is there anything in particular you'd like me to show, or would you just want me to go through this design um, and see what it is that I see?
Yeah, if you have a couple points of feedback, I know you do a lot of these PCB DFM reviews on your own. So if we have any notes on this one, if not, we can also move on to other workflow changes.
I'd be happy to take a look. If you want to pass it over to me, I'd be happy to share.
Sure, let's do that.
This will stop the other person's screen sharing. So yes, I want to continue, and I want to share my tab. All right, am I live?
Sure are.
Okay, or I guess I could make it a little smaller so it's easier for you guys to see. Does that improve things? I hope. All right, so this is our first board that we've done that looks so long and so skinny. The other ones, just so people know, we did one more in the pre-trial run, and it was actually a much better aspect ratio that made it easier to work with. So that might be something to look on your roadmap to add. But this is an unusually long board, in my opinion, anyway. But that's Harris. He likes being difficult. So let's take a look and let's turn off all the layers. And I'm just going to start and I'm going to look at the land patterns, hopefully. So let's see if we can get the top layer. So this is just our copper and our traces for things. So one of the things that I'd be looking at is, like this pad, does it match the part? If this is an 0805 resistor, is it actually an 0805 package? Or is it an 0603? It's really, really common for engineers to screw things up like that, and it's not really their fault. There's a lot of overlap between the EIA and the metric system when it comes to parts. So when you go pull a part from the DigiKey or whatever, and you look at the part number and you see an 0603 in there, is that an 0603 EIA? I'm sorry, a 10005. Is that an EIA or a metric 10005? There's overlap, so you have to be very careful with all of those sorts of things. Here it looks like we've got a trace intersecting a via. That might be something that we need to look at to make sure that the via is not accidentally creating a short on the trace. So I'm just going to snip it there and see if that doesn't accidentally create a short circuit. It might not if they're on the same net, but I don't think they are. Um, do we know which is the... See, that looks like that via is definitely intersecting that trace.
Mm-hmm.
And that via looks like it is part of a ground, possibly a ground copper pour. So we could have a short there that we don't want. So I'm looking for stuff like that.
Okay.
Same thing happening here. I'd be looking at the land patterns. I'd actually go and take this. It's a really weird package. Looks like a thermal TSOP. 1, 2, 3, 4, 5, 6, 7, 8, 16 pin thermal TSOP, and I'd go and I'd get that. One of the other issues that we have here is this copper pattern here. This will cause solder wicking. And I'll explain that in a second. And is it 7351?
Yeah, let me check. IPC 7351.
See
You want
if
to keep
that's...
going? We can also edit the.
Yeah, see if that's land pattern for
I see
thermal packaging.
generic requirements for surface mount design and land pattern standard.
That's
So,
the one. Okay, so let me explain that to our viewers who are wondering why I care about that, because that probably looks pretty standard to a lot of people. Well, the issue is that since you have vias that have open holes, solder is going to leave this pad and it's going to enter the holes. That's going to leave insufficient solder between the package and the package pads and the land pads. You're going to get an air gap. That's an issue because air is an incredibly good insulator. You want a good, strong thermal connection. However, the best way to do that is really expensive. If you cap and fill those via holes, right? The solder can't go in, but that is ridiculously expensive. The next best thing you can do is shove some LPI solder resist mask in there, right? Just cram it full. That works, but again, expensive. It's an additional process. Well, IPC 7351 provides some patterns that you can put on those land pads. Basically, you create solder dams around the holes so the solder can't get in. Well, LPI is free. It's going to be on your board anyway. So that's usually the recommended option that we give people because it doesn't add any expense to the board and it solves the problem.
So that's like a paste mask, Mark. That will keep the solder from encroaching on those vias. Is that the idea?
Yeah, it's not a paste mask, a solder mask.
Solder mask.
Yeah, it's exactly that. It just creates a bunch of dams with the LPI, the liquid photoimageable solder resist. Other things I'm looking for, I don't think it's a problem here, but I saw it elsewhere on the board. Do we have drills that are too close together? I did see that in a spot, but it's probably going to have to wander around till I find that again. pardon me here. And I'm just looking, same thing here. We've got the same issue with a different part, that TSOP 14.
And as you were scrolling through, Mark, I'm going to try to find it again. There's a couple areas it looks like, maybe this was a config setting that they had where, almost all of these traces here are 45-degree angles.
Right.
I guess this is something I've wondered a lot as a designer as well. It looks like some of them are not. Like what you're looking at right there is not quite a 45-degree angle. It appears as if, maybe the setting got changed or something like that. Is that a problem at all for manufacturers, or you tend not to care? Is that just a stylistic thing?
It's a stylistic thing. So when boards were originally made, if you can still see this back in the 60s, 70s, 80s, you'll see that these traces are run point to point. And the way that they did it was they actually had boards, acetate, they would actually run tape, right? Well, then the first CAD CAM programs came along, and only thing they could do is route at 90 degrees, right? We're talking Commodore 64, Apple IIe era, and shortly thereafter. After that, we got a little more functionality when, sorry, I'm just looking. Next, I'll look at assembly. We got a little more functionality when 45 degrees came into play. But our can't think of the right word, but our penchant for
Literally
running
a
things,
whole new dimension for you to play with.
yeah,
45 degrees.
right? But our penchant for running things at 90 degrees and 45 degrees is completely artificial. It comes from, 4 decades ago when that's all computers could do. You could run these things point to point. It would be absolutely fine. It's not an issue at all. All right, so this is the assembly drawing, and what we're looking at are presumably the courtyards, although it's not really labeled, so I don't really know. And one of the issues that I'm seeing here is courtyard encroachment, right? These areas are supposed to be keep outs where you need that space, so when the pick and place machine, and these things move fast, right? They're flying. These components are getting, 2, 3, 4 Gs of acceleration. Well, when this thing comes flying over, you don't want whatever part this is that's already down to collide with this piece, or this piece as it's coming in to collide with this piece that's already down. So courtyards are important. The other reason that we have courtyards is that if we need to do any rework or repair, we need room to get in there to do it. So
Yeah, it almost seems like some of the courtyards on these components need to be updated. You know what I mean? Like the courtyards and underlying components I'm looking at, if you toggle the overlay on, you can kind of see maybe a little bit more where they had intended the components to be. And some of them will look like just don't quite line up with their
yeah,
underlying ones. So
it could
maybe an update to these
it could
components
just
would
be,
be
yeah, it
helpful.
could just be a library issue, and it could be that I'm looking at the wrong thing. But if these are in fact the component outlines, those, that is a really big courtyard for that, whatever the heck that component is.
Right.
But IPC defines that too. So you can have these things in the least the least nominal and most land pattern overhang configurations. So let's turn off the mechanical for now, and let's turn the top copper back on and see if we can see. But you can actually define how much of a courtyard overhang you have. You can define how much of a copper land pad overhang you have, and yeah, you can do minimal and you can get parts really close in there, but we can't rework that. The things are going to be too close together. It's going to be too much of a pain in the butt. Nominal's fine. The most land pattern overhang condition is when you make these land patterns as big as you possibly need to make them, and that's real easy to rework. But it kind of leaves a little room left over on the board. So nominal's good. Only do the least if you're doing like a smartwatch or something and you just don't have the space. So let's take a look now at our via holes, because I do remember somewhere, maybe I'm just imagining it, but I remember seeing some via holes that I thought were too close together. And maybe I just was looking at the wrong thing. But we'll use these as an example, right? If you put the holes too close together, um, the drill can actually break through the PCB, right? The drills wander ever so slightly. There's going to be less force coming from the side of the drill hole that has a hole right next to it than on the other side. So then that can cause the drill to wander into that hole. So manufacturers usually require some minimum amount of board between two holes. And that can vary anywhere from, an eighth of an inch down to, 0.1 inches. It just depends on what you're doing and what machines they're using. So, all right. I've been talking for a little bit. You want to drive again? Or do you want to
Sure,
take some
that sounds
questions?
great. Yeah,
Take
I'm
some
curious if
questions?
also maybe it's a good time to pause, see if anybody in the chat has a question on the design best practices on PCB for manufacturing, or not. If anyone does, feel free to put it in the chat. I will grab the driver's seat now.
Okay. Well, we don't have any open questions yet, but hopefully somebody will get brave here.
One thing I will do, and maybe this is just me, I'm curious if you ever see these notes at all in the manufacturing process, but one thing I like to see is just, especially since this had caused us an issue, can, can we update this with some notes on the feedback voltage? Why do we pick these values? What's the output? Like that quick, calculation for what feedback voltage is going to result in what kind of value here with a comment.
Oh, we have our first question. Would we like the questions in chat or the Q&A? We would like the questions in Q&A, please. Thank you for asking. So you want to know why that value got changed? What equation was used for it?
Yeah, and we could of course do it in here in the design review, but ideally, I think if I'm owning this design, I would like to see just a quick note in here. Hey, comment, this feedback resistor pair is going to result in this kind of output voltage. So if we ever do come back and change it, especially some of these, you have also kind of this filter, RC filter set up to kind of just why these particular values were chosen, so that someone reviewing this design can have something to go with.
Okay.
When they're reviewing.
So they can double check the math, essentially.
That's my idea.
I think that's a good idea.
Okay, so in the end, do we have any questions for to go over Q&A?
We did just have the question of would we like questions in the Q&A or in the chat, and we answered that. We would like them in the Q&A.
So it sounds like they had it right the first time because it was posted in the Q&A. So
that was our first question, and it was a good question, and I liked it, and I'd like more. So Mark,
absolutely.
If you're still out there, keep them coming, buddy. I like those ones that come nice and slow right over the center of the plate. Those are easy.
Yep, we've given you the tools. Now we can put them to use. Mark, so one thing to do is to submit your feedback. So there's kind of two selections here. This is kind of just jumping back into the process. I'll maybe go here. When you create a comment, we can either add it as a single comment, and that just kind of throws it right in there. If you have notifications set up or whatnot, it can be kind of annoying where you're getting pinged again and again, hey, new comment. So you've used the Start Designer view, which is great. Of course, I've just selected nothing, so it's not very exciting. So what you can actually do is if you go into the top corner, you can provide some final notes, say, looking good so far or whatever, how you have you. And you can actually submit, approve, request changes, or comment. So actually, if you want to go ahead and do that, then I will be able to see some of your pending comments there.
Sure. So walk me through that again.
So if you go to the top right corner, you should see this drop down for review.
I got it.
And I believe you can throw in some notes if you so choose.
Yeah, let me put in a note real quick.
And then select one of the three options for submitting. And then that will actually give the feedback back to, in this case, me as the design review owner. Whereas currently they are in a pending state. So we kind of have this, requested for review.
All right. So I really hope Mark Harris is watching right now because I'm writing a comment just for him.
Perfect.
Okay. So I hit approve.
If you want to approve my review, if you want me to make some changes, probably
I'm going to have you make some changes.
All right, let's go for that.
So if you refresh, you should see that now. I hope, if I did it right.
Here we go. So yeah, so this is essentially what we see.
And I wrote, Kyle, Mark Harris's layout is absolutely adorable. I love watching new designers learn how to do things the right way. And Mark has so much to learn.
There we go. Some constructive criticism.
No, I'm just insulting Harris. He's actually really good.
Yeah, this is great.
We're friends though, so it's okay.
Absolutely. And so yeah, you've made a lot of our designs. If this was a real design I was truly working on, we could go back, make some changes. I could push a new version. You'd see that come up here in the history.
Mm-hmm.
And we could, I'd re-request you for review. If I wanted to say, hey, take another look at it. In which case you could go through the process. Yep, you fixed the changes that I wanted you to. For instance, as we go through, I would say, as the design review owner, I have a few options for how to handle this. You say check the courtyards. I went through, took a look at them. They all look good. I'm going to say, I could give you a reply if I'm nice. Yep.
And then we do have questions now. You'll be happy to know.
Oh, perfect. So I can say all set, they're looking good and I can resolve it if it's all set. Alternatively, and you'll see, yeah, here we have resolved this conversation by default, it'll kind of collapse itself. Now, if I, as a design reviewer, instead say, this is not really in the scope of this design. Hey, we're doing this in all of our designs. If we want to change this, we should really run a concerted effort to get a bit more information about it. I can actually escalate this, create a whole issue out of it, review all designs for IPC 70, 73, 51 compatibility. Oops, don't judge my my spelling here.
All right. We do have a question. It said most of this is about PCB or about PCB layout. And I believe the comment there Mark is making is that, well, okay, this is great for PCB layout. What about schematic? And to answer that, we can do the exact same thing you're seeing here over on the schematic. It's just schematics are a little harder to do in a webinar just because it ends up being a lot more technical. So maybe make a comment on the schematic just for people to see how that works.
Yeah, absolutely. So one of them, updating comment feedback with values. Of course, we can really select anything here. So, one of the things I think we've mentioned here is just why do we go with 2?
Exactly. Exactly. Why? You don't need 2, Mark Harris. You don't need 2. You need different package sizes if you're worried about that. It's old school. Back when we had plated through holes, if you had 2 different size of capacitors, well, they had actually 2 different size package sizes. So they had different inductances. So if you're trying to avoid a resonance, you don't need an 0402 1 microfarad and an 0402.1 microfarad. You need a 0402 and an 0201 of the same value. Exactly. Good looking out. Good looking out, Kyle.
Yeah, so in this case, we have an 0603 on the left. We have a, let's go back to the attributes, device package. We have an 0603 on the right. So the same package size, 2 different values. So does that kind of imply they're the same package size. They're going to have the same,
The same
inductance,
ESL, yeah.
resistance. So we're
If they're
not really helping ourselves here.
exactly, if they're the same dielectric, same package size, same everything. So you would want to move one of those to an 0402 or an 0804. Gosh, I can't think right now. Anyways,
Gotcha.
but yeah, you would want to do that if you're worried at all about maybe some potential resonance. So
Got it. And
anyways,
those are going to have kind of big, different characteristics, kind of like, innate characteristics, because, if we're making one larger, one smaller, presumably the bigger one's going to have a lower resistance. The smaller one's going to have a lower inductance. Is that kind of the idea?
yeah,
Okay.
that is the idea. All right, we've got a ton of questions now. If you want to go over to Q&A, and we'll just start zipping those off. Thank you, by the way, for participating in our webinar today. We appreciate it. Daniel and Mark and John and Anonymous and Mark and John.
Yeah, and there was another question here. Can we see the manufacturing data for the components in the schematics? You might have seen part of that. Yes, you can see the metadata that comes right from your design tool. If one of those, and I don't believe we have anything here, we might. Yes, okay. So we can, we should really update to make this clickable. But of course, you do have the link here we can start using. So it is embedded in there.
Okay, so yes, it's just might need a little more GUI work, but it's there. Cool. Okay, which one do you want next?
I believe the next one's a follow-up from Mark. I think following up on his previous question about PCB. I'm asking about manufacturing machine limitations and how this affects PCB designs. Do you know what he means by skyline of parts limitations? That's outside of my wheelhouse.
So I believe I understand that question. So as you go to different manufacturers or different, even different assembly lines for different manufacturers, you're going to run into different tools with different limitations, right? Let's say I go to Royals Hollister campus where they buy new equipment every year, like, they're printing money on trees. It's great for designers because you get the latest, greatest, absolute everything. The stub drill distance, is a little more accurate. You can do a little bit more of this. But then I go over to, Joe's PCB shop, or I hope that's not a real company. I'm just trying to make one up. And, he hasn't bought a new drill machine in 10 years or a new pick and place in 15. And you've got to adjust your design for the equipment that's going to be used to assemble it. I believe that is what Mark is asking. Mark, if you want to clarify, that, please do. And to take it to another level, what assembly technique are you using? Are you going to use solder, paste, and reflow? Are you going to do wave solder, selective solder? Are you going to do hand solder? All that type of thing, it does impact your design. So I think that is what he's asking. Is there a way to build manufacturing limitations into the PCB design process in AllSpice? And I'll answer the question for you. Not at this time. That capability does not exist in AllSpice at this time. Remember, AllSpice started in 2019, right before the height of the pandemic. So this is, it's got a lot of features, but there's going to be a lot more features to come. So, Mark, if you want to expand on that, or if you even want to go live and we can put you on audio, I'd be happy to do that. I hope that starts to answer your question. All right.
Yeah, we got a follow up. He says, I think we nailed it.
Okay. Cool. All right. Next question you would like.
Awesome. So, one question we have is basically, someone coming from software background, with us and our company pulling from software best practices. The question is around whether there's automatic checks that can be run as part of the PR. For those who don't have context, the GitHub. Well, there's several different layers in the stack. Git is the fundamental technology that we're running on, and also that GitHub, GitLab, Bitbucket, some of these other tools for revision control are running on. GitHub was basically developed probably about right around 10 years ago now. It started to really hit the mainstream, and really opened up the world for automated design checks that are run in the cloud. Software calls these CI/CD, continuous integration, continuous development. It is one of the tools that have evolved in the software space to make it very, or at least significantly easier to make quick designs on changes on designs. Idea is that we've built in a lot of tests up front. We can check for things like, we've given the input constraints and we've tested for, we're asserting the equality on the outputs, and we're making sure that if I make a change somewhere in the middle of this black box, that input output equality still hold true. That is one of the many checks you can do in software. So this is all an area that we're actually very excited about with AllSpice Hub. Of course, there's all sorts of checks that we're adding to be able to run things like stock supply chain analytics. And what we're actually working on is later in the year to be able to also add additional checks for things like component performance. That would be like running Spice, running simulations in the cloud. Some of you may have also gleaned that our company name is obviously derived from the simulation space. So definitely an area that we're really excited about.
See, we had an argument about that between myself and my colleague. We didn't know if it was from Spice, which was my thought, or his thought, you guys were foodies.
Yeah, starting out the company early on, we did some pitch competitions, and we had a lot of I would say disappointed panelists on occasion. We didn't bring in food samples, especially when some of our contemporaries were bringing in food samples.
Yeah, absolutely. All right, which one would you like next?
We can keep going down through. I have a question about, I think this is from John. Asked a question about project files. I'm not entirely sure. The question is asking about maybe if I'm inferring it correctly, would be a better or basically a better view for how designs or what files in designs are included in project PCBs, which would be definitely something that's quite helpful and something we're working on. So be a little
I
bit more info about the project.
um can I think what he might be getting to, or at least if not, maybe it's an interesting question. How do you go from Altium to AllSpice? How do you
Yeah,
go from there to
that's
here?
another fair question. I can see if I'm brave here. I can change my sharing to be at the screen level.
All right.
And I can
And
even give a quick
while you're preparing for that, let me take another question, okay? And that'll give
yeah,
you
why don't
time
you?
to get set up for that. Anonymous attendee says, coming from software background, one of the most useful features of GitHub PR reviews is the ability to have automatic checks run as part of the PR
That's the one
process.
I was just running through.
Yep.
DR automated checks with CI/CD.
Yep. Are there any plans for AllSpice Hub to be able to run the equivalent of unit tests on designs, e.g. distance between holes, space between components, voltages going to particular component, etc.? And that was your thing. But I would also like to add, it should be possible to integrate the Numeric Innovations is the company, and they make a really sweet set of software called Fab 3000, I want to say, and they came out last year with a cloud version. But basically, you create what they call a mesh file, and you submit your thing to their cloud servers, and it's like a nickel a minute, and a job takes like a minute. It's dirt cheap. Um, it should absolutely be easy for you to integrate that. If you take advantage of numerical innovations, um, you can do a full DFM, DFA analysis on your design for pennies, absolute pennies. It would require somebody with a software background to perform the integration for you, but it's not terribly difficult. A junior developer could get it going. So yes, there are ways to integrate action files just like GitHub and make things work inside of AllSpice, and you can also integrate external tools. It takes a little bit, but you could do it.
Yeah, absolutely. I mean, one thing for there is, we built around an entire API. So pretty much anything you can do in the user interface can also be done through an API. And that might be one of those cases where pulling from the API might be something worth doing.
Yeah. And if Kyle, I guess I should ask, have you ever heard of numeric innovations?
I have not, but I just saved the web page, so I'm gonna go take a look at it.
Yeah, we should have Mary write that down.
Yes, our Mark is referring to Mary, who's helping us out with our marketing intern. She's been a champ getting everything set up for today, so thank you.
Absolutely. All right. Hopefully that gave you enough time to.
Oh yeah.
Perfect.
Yes, absolutely. So what I'll do is I'll share my screen, and there's a few things we can see. So this is the same design I have locally. Let me pop it open in Altium. Hopefully there are no issues there. So one of the things you can do is you can see that all of these files and folders, they have a check marks next to them. That's because I'm using a Git client called Tortoise Git. Some of you might have used Tortoise SVN in the past. It's the same thing, just with a Git backend instead. See if Altium doesn't yell at me for license issues or anything like that. Oh, just thinking. So what that allows me to do is it provides a graphical user interface for me to help manage my hardware designs. So in this case, I can see that same design that we were just doing reviews on. We were on this develop branch. We have lots of information about branching that we can go into at a later date. We do some tutorials on our website as well, but essentially shows me if I have any local design changes in my working history. So this is my last committed design. This is my working designs, which is, you can see there's no changes here. If I were to make a quick edit here, perhaps this gets moved. Of course, we could come up with something more interesting. There are essentially a couple ways to update this design. So one is, you can see now, if I use Tortoise Git, I can see there's this design change, and there is also a local version of AllSpice that I can run for the diffs. Which also shows me that, because I'm using a new version, of Altium, that I've actually updated my unique IDs for these components. So compared to what the old version was. So among other things, can help you kind of catch when Altium is changing things that you had not expected. But you can see also this position has been updated. But anyways, that's the local tool. If I want to say, commit changes, I can add a little note. Commit and push that if I want. I think I'm all set up with my permission keys. Yep. And I can actually come back here, and if I go to my designer view, previously I had 2 commits. Now you can see I have 3. So I've added this new commit here, just to kind of really blaze through a lot of things. You can see just the change that I just made by clicking that specific commit, or I can see it in combination with all those other design changes we were just looking at. In this case, it's, this component was deleted when this thing got moved over, because this was also part of the total design change, which is interesting. Yeah. So that's basically the real lightning fast way that you can kind of get between the two tools. There's also a way to basically, if I make another change, push directly from here as well. I think you go under history version control, you can go commit, and I can do the same thing through here.
All right. Sorry, my Zoom crashed there for like 4 or 5 times in a row. But we've got
Oh,
another question, and I think it pertains to what you just had open. Sorry, I
okay.
didn't get to you sooner. But
No, I'll
a
jump
lot
into it.
of a lot of engineering groups don't have one design. They've got 50 designs.
Sure.
So what does it look like when you're in, John asks, when you've got 40 projects active in a design group?
Yeah, absolutely. And that's a great question. We actually recommend one repository per design. There are more advanced ways you can link together different designs, but the idea is that you can set permissions separately by, each of these are design repositories that I have. So if each of those is the scope of a design file, it's the best way to kind of keep things organized. You can run design reviews per design. If you have if you need references to other designs, you can of course always link to them easy enough. You can actually even link to specific versions. So if I want to think I can just view file, maybe there's a more interesting, that diff wasn't very important, but if I took a look at this history, I can kind of come in here and say, I can provide a link here. I'm not sure if it comes through on the Zoom connection, but this actually includes the specific version. So you can send a link with a specific version. So if I'm doing a design review in another project and say, hey, we need to take a look to make sure this is compatible with this board, you can make sure it's this board at this version. There's more ways you can basically do. You can tag versions as releases for shorthand. So if you have, version 1.0, you can essentially tag this big long, it's called a hash, with the version. We won't get into that today, but it's another shorthand way to basically provide a link to a specific version in time. And that's one way you could combine, multiple different repositories together if you need it, if you had multiple designs that were dependent on each other.
All right. Well, let's go ahead and finish it up here. We're approaching the top of the hour, and we want to be respectful of people's time. But the last question that we have pertains to closing this out. How can I get a copy of this recording? Once available, it'll be at aapcb.com/blog. And usually we can get that out in a couple days. Sometimes we edit them down, but I think we can just put this one up in its entirety. And John, you said we agree on repository per project and would like our SolidWorks, ACAD, and Office files in the same repository if we can do that. So probably what you're going to want to do is email Kyle and set up a one-on-one conversation and have him talk to you about your needs and see if AllSpice can maybe help you out with that or not, or maybe it needs an integration of some sort. So,
Yeah, sounds great.
Kyle, would you like to put our emails back up on the screen?
Yeah, why don't I do that?
Thank you, sir. And with that, I would like to thank all participants for joining us today. It was a lot of fun. We learned a lot. Especially like to thank Kyle Dumont of AllSpice, Robert, is it Byrne? How do you say
Yeah.
Robert's last name? Byrne.
Yeah.
Um, and what is the last name of our intern? Who's your
Pollard.
intern? Pollard. And Miss Pollard for joining us today. It has been a blast. Thank you all for meeting us and everything. You can email me at mhughes@aapcb.com, or probably it's best, since this is all technical and it relates directly to AllSpice, just send all your questions straight to Kyle at allspice.io. I don't think there's many questions, technical questions I can answer past the ones I've already learned. I don't know enough about the software yet. So email them directly. Kyle, any closing comments?
Just thank you, Mark. I know I learned a few tidbits here too, which is great. It's kind of what I was looking for.
Oh, good. That's what we're always here to do, is learn whenever we can. So thank you again, everyone. Have a great rest of your day, rest of the week. And if you do have any questions, email sales@aapcv.com. Take care. Bye.